Can you see that okay?
Yes.
Great.
Yes, we can see.
All right, good. Thank you very much. So the title of my presentation is Water Security and Climate Change in Africa. As the introducer said, I have worked for many years on this topic, and I was thinking about when I was preparing the presentation that it's now 30 years since I finished my PhD, and my PhD was on climate change and the River Nile. So since I finished my PhD, I have worked on the Nile on and off, but not very much recently. But yeah, 30 years ago, I finished some research work, which was all about what might happen to the River Nile flows in the future because of climate change. And that was 30 years ago. So things have moved on a lot. When I did that work, there were very few people studying climate change, and it wasn't really a priority. And to have seen it grow into such a major global environmental and social challenge has been fascinating through my career. So I'm going to start my presentation by talking a little bit about the Nile. I have to say it's quite a few years since I did any new research on it, but I want to use that as an example to introduce to you the idea of some of the challenges that climate change represents for water resources, particularly in relation to water availability and the variability of water resources. Then I will move on to show a few examples from other parts of Africa where I've worked. One of those is looking at the socioeconomic impacts of the El Nino climate phenomenon that affects different parts of Africa, including the Nile Basin. And the work there that I will talk about is primarily in Zambia, and it's looking at socioeconomic impacts. Then I will use an example of the Rufiji River Basin to highlight some of interdependencies or the multiple sector impacts of climate change as it affects water resources, energy resources through hydropower, and food production through irrigated agriculture, and to emphasize the importance of trying to look at the different sector impacts together rather than in isolation. And then I will end with some key points that come from the work that I've presented, and to help us think about how we might deal with climate change in the future. So when we talk about climate change, of course, we're talking about the global emissions of greenhouse gases through human activities. Since the Industrial Revolution, the emissions of greenhouse gases through the burning of fossil fuels and other activities have increased very substantially, particularly since the 1950s. And that's causing the problem, an impact on the global climate system, which is already showing evidence of warming. We're about 1.1 degrees warmer than we were before the Industrial Revolution now, and we expect temperatures to continue to warm into the future, and there to be associated with that other disruptions to the climate system. And the scientific knowledge and understanding of that is we're very confident in that understanding. So there are two potential areas of response to this. The first is mitigation, which is on the left-hand side of the slide. And mitigation is about reducing emissions of greenhouse gases, and it's very important, crucial that we work hard and continue to work to try and reduce our emissions of greenhouse gases. But at the same time, it's become increasingly the case that we will also need to adapt to the changing climate. So we are already experiencing changing climate, warmer temperatures, changes in the frequency and intensity of extreme events such as heat waves and droughts. And how society responds to that we call adaptation. So we are responding as events happen, but we also need to think about how do we plan for the kinds of changes that could occur in the future in order to make society secure or resilient against climate change as it continues to occur moving out into the future. Even if we stopped all our emissions of greenhouse gases immediately now, we are still committed to a continued warming. And so we therefore, it's important for us to consider adaptation. And my work and this lecture is all about adaptation. And it's trying to understand how important is climate variability and climate change for water resources, and what are the kinds of responses that we could make to the impacts of climate change on water resources. So I'm going to present that to you. By way of introduction, I wanted to say a little bit more generally about climate in Africa and in North Africa, but also sub-Saharan Africa, and some of my examples will draw from sub-Saharan Africa. So when I started my PhD in the late 1980s, there was a lot of concern about the impacts of drought in Africa. So there had been a major drought in West Africa, in the Sahel region during the early 1980s, 1983, 1984, very widespread reduction in rainfall, and associated with that, water scarcity, drought, impacts on food production, and very extensive impacts on food security, leading to famine. And the understanding and awareness of climate and Africa was very much around drying, around drought, around the impacts on food security, limited water availability, and so on. And that narrative of climate and Africa has continued very much to be an important part, I think, of sort of public awareness of the role of climate in Africa and some of the challenges that climate represents to Africa. But increasingly, I think it's important for us to recognize that the nature of the challenge is also changing as society changes across Africa. So we have seen, or there continues to be, rapid population growth across much of the continent, and a strong trend of urbanization. So that urbanization, whilst most of the continent is still rural, there are about 43% of the population living in urban areas, and that percentage is projected to grow to 50% by 2030 and to increase onwards, given a rapid rate of urbanization. Africa's population is about 1.1 billion at the moment, and that's expected to double by 2050. So the numbers of people living in urban areas are increasing rapidly and will reach very high numbers by the midpoint in this century. So the nature of the climate challenge, of course, the drought is still important, and water availability and water scarcity is a significant challenge. But at the same time, we are now seeing significant social and economic impacts related to urban areas. And those are in association with flooding events in urban areas, but also in relation to water scarcity and drought events, such as the very high profile Day Zero in Cape Town around 2017. And in addition to that, there is also impacts relating to, in terms of important economic impacts with hydropower. So for many African countries, they are quite highly reliant on hydropower. Egypt, for example, a few decades ago, had a much higher reliance on hydropower, not so much now. But nevertheless, other countries in the continent have a very high proportion of their electricity production from hydropower. And that, of course, is exposed to drought. So if there is a one dry year or multiple dry years, that can lead to reductions in reservoir levels and impacts on hydropower production, affecting electricity supply, disrupting electricity supply, and leading to quite significant economic impacts in different parts of the continent. So we're seeing new types of hazards and impact combinations across the continent, with a lot of important impacts in urban areas now, and that's likely to continue in the future. And some of the examples I will show are very much about urban impacts, and that will be using a case study of Lusaka in Zambia. So here is my example from the Nile River. And as I said, this is from some time ago, so it's a little bit out of date. I haven't updated the data set that I'm going to show you, but I think the example still highlights some of the challenges that climate change represents for water security. I think you will be aware of the geography of the Nile Basin. And my map here shows the physical river basin as it drains 11 countries in equatorial East Africa and the Horn of Africa into North Africa and into Egypt. The point that I wanted to make with this slide and the map is to emphasize that, of course, there is the White Nile system with Lake Victoria draining Uganda, Tanzania, and draining and South Sudan, flowing through the South Sudan into Sudan. And then on the eastern side, there is the Ethiopian highlands and the Blue Nile draining that region, flowing into the Sudan and joining the White Nile at Khartoum. So the point to note about that is that each of those regions has different influences from the climate system, and particularly the El Nino Southern Oscillation that occurs in the Pacific Ocean. So I've highlighted there for the Ethiopian highlands, they have a strong influence from El Nino, and during El Nino events, we tend to see lower than average rainfall over the Ethiopian highlands. Over East Africa, we tend to see higher rainfall during El Nino events, but there is an influence from the Indian Ocean through a phenomenon called the Indian Ocean Dipole, and that is if it occurs during an El Nino event or separately, it makes a slight difference to the consequences for rainfall, but both tend to bring higher rainfall during those particular years. So we are now potentially moving into an El Nino year. So not all El Ninos are drier than average over the Ethiopian highlands, but it might be the case that we have, as we move into a strong El Nino event, then it could be lower than average rains over that region. This influence from El Nino over different parts of the Nile Basin is one of the strong influences on the historical variability of flows within the Nile River as they flow down into Egypt. So my slide here shows a little bit about the history of Nile flows. So you may be aware of the Nilometer on Rhoda Island in Cairo. You may have visited it at some point. So that's a historical site where the levels of the river were measured on a regular basis, and there is a historical record of flows of the Nile going back to the 7th century AD, and even longer than that. There are some intermittent records for flows of the river where the authorities were interested in the level. Would it be a wet year? They could set taxes higher during wet years, or if it was a low year, set taxes slightly lower because of reduced irrigated agricultural production during those years. And given the importance of the water availability in the river to the country, obviously it has been studied in a lot of detail for many years. The lower panel in my slide shows for the more recent historical period from 1870 up to the early 2000s, it shows the annual flows of the river as measured as one, and how they have varied over time. And each bar represents the flow of the river for that particular year, and the dark black line represents the moving average of river flows. I want to make with this slide is, if we look over time from the 1870s to the early 1900s, was a period of much higher flows over that period of time. And then during much of the 20th century, we see a significantly lower but stable level of flows until the 1980s. And this 15-year period here, lower than average flows. And it's this low flow period during the 1980s that I wanted to say a little bit about. But the shifting mean in the flows of the river gives us an example of the challenge that future climate change represents. So what can we say about the availability of water moving into the future in relation to the flows of the river? So will we see periods of high flows or a maintenance of the long-term 20th century flow levels? Or will we see events such as the prolonged period of dry flows during the 1980s? Will they appear in the future? What we can say with certainty is that there is likely to be greater variability in the flows of the river, but we don't have high confidence to be able to say that conditions will become wetter or they will become significantly drier. At the moment, the level of the science and our understanding of being able to predict rainfall over the source areas of the Nile is limited in terms of our not being able to give us high confidence in about how they may change. At the moment, there is looking at different climate models which are making projections about future rainfall. The majority of those models suggest it may get a little bit wetter in the future, alongside there being higher levels of variability. So this is from a short piece that I wrote for Nature Climate Change, the academic journal, which just summarizes what the current state-of-the-art understanding about Nile river flows and their future behavior might be. And the quote there is that climate change is projected to increase annual Nile river flow, but importantly, the year-to-year variability is also expected to increase markedly. And more variable flows could present a challenge for the consistent provision of water resources in the region as we move into the future. So the take-home message, in a way, is that we have uncertainty about the future, but it's very likely to be different to the current conditions, and therefore we should be thinking and planning about those sorts of changes and what their implications might be as we move into the future. So the final slide about my Nile example is a time series here. The top plot shows the level of the Aswan Dam reservoir, or Lake Nasser, from its construction up to the early 2000s. And the point I wanted to make here is just to track through a little bit of the history. After the dam was completed, there was a very, very rapid infill or increase in the levels of the lake as the river came into the reservoir, and the levels built up over time during a period of humid, high rainfall, high river flows, and led to the filling by the mid-1970s. And as you can see there, this is the level of the river of the reservoir, sorry, the Aswan Dam. So moving into the 1980s, as my previous slide showed, there was a period of extended dry rainfall conditions over the Ethiopian highlands and dry or lower than average river flows. And that led to a reduction in the level of the reservoir, as you can see here with the time series, through to 1987. So there were last-minute implementation of drought contingency plans to restrict the outflows from the reservoir because of the danger of the level of the reservoir going below the operational level to maintain hydropower and consistent outflows for irrigation water availability. But that was saved by a very high flow year in 1988, this point here. So in fact, there was flooding in Khartoum because the Blue Nile flows were very high that year. And that began a period of refilling of the dam as we moved into a much more humid period over the Ethiopian highlands, and a series of wetter than average years, which allowed the irrigation department to fill the dam and to continue outflows and the maintenance of hydropower during that period of time. But interestingly, of course, because in the mid-1980s, Egypt was brought very close to having a severe water supply crisis, that led to a response which comprised a development of a Nile forecasting center to try to predict the flows of the Nile, to manage the reservoir releases more effectively if there was a return to the dry period, and a development of technology and awareness and interest in water demand management, understanding how water was being used, what water efficiency levels were in different parts of the country, in different types of agriculture, and with a lot of emphasis on thinking about water scarcity. As things continued in a situation where Egypt had high levels within the Aswan Dam reservoir, then that after a period of time, I think the emphasis on water scarcity and water demand management perhaps eased off a little bit. And because of the availability in the reservoir and for other reasons, there was an interest in actually expanding the irrigated agriculture, which potentially might be a maladaptation, because if there is a return to dry flows in the future, then that would create problems with maintaining water availability in that situation. So that's a long vignette, a story about the Nile and the flows during the 1970s and the 1980s, and the implications of that for water availability and for the management of water resources. And I wanted to use that as an example just to highlight the significance of variability, shifts between wet periods and dry periods, what that means for water availability, and the significant consequences that there could be in relation to maintaining a sustainable supply of water for both irrigated agriculture, but also hydropower. I'm going to bring that up to date with a different example now. We're going to move from the Nile to further south in sub-Saharan Africa, and I'm going to take an example of looking at the economic effects of this type of variability. For this, I'm going to use an example from the El Nino event, the major El Nino event that occurred in 2015 and 2016, and look at, in particular, the hydrological impacts upon electricity supply in Zambia, in the capital city, Lusaka. And this is related to work that I was involved in, where we were also looking at the El Nino related floods in Nairobi, and also water supply disruption in Gaborone in Botswana, associated with the drought conditions that El Nino brought for Southern Africa. So actually, like the Ethiopian highlands, which tend to be drier than average during El Nino events, much of southern Africa tends to be drier during El Nino events. Not always, but that is often the case. And it was very much the case during the 2015-2016 El Nino. So the map here just shows the Zambezi River Basin outline, and the Zambezi has a major dam on it called the Kariba Dam, and the Kariba Dam supplies electricity to Zimbabwe and to Zambia. And during the drought in 2015-16, there was a major impact, low river flows and inflows into the Lake Kariba reservoir, which led to a disruption of hydropower in the Lake Kariba system. And that led to disruption of electricity production, or led to load shedding in Zambia. And there were significant economic impacts of that. So we see here from the slide, this is a newspaper article which talks about the significance of the economic impacts of drought-associated disruption of hydropower production. So in Zambia, in May 2015, the water levels at the Kariba Dam reached their lowest level in 20 years. There were management strategies which were put into place, but these were insufficient to avoid disruption of the hydropower generation. Zambia's electricity utility had to cut supplies of electricity by about a third across the period of 2015-2016. And during that time, the Minister of Finance reduced the national growth forecast by 1.2% of GDP due to the power rationing. So just to emphasize the macroeconomic impacts of these types of events in countries where hydropower dominates the electricity supply and there is a sensitivity to drought. So in the project, we were interested in trying to understand what the significance of electricity supply disruption was for small and medium enterprises within the country. So we undertook a survey of what are small businesses, agribusinesses and service sector businesses, to look at what were the impacts of the load shedding within the country. So the business impacts related to power supply disruption over the previous 12 months during 2015-2016, prior to the survey, and then SMEs, small and medium enterprises or small businesses, their awareness of El Nino and how much information had been imparted to them or shared with them about early warning about the El Nino occurring, about the potential impacts of El Nino and the consequences for hydropower and electricity supply. Were they aware of this, and were they able to undertake any responsive actions to cope with the impacts of the load shedding? And then finally to ask about what were some of the barriers to those coping strategies or implementing those coping strategies. The results of the survey are shown here, and what we found is that the small businesses were renting or buying diesel generators to generate electricity to offset the blackouts. In some cases, staff were laid off, if on a temporary basis, or in some cases permanently due to closure of the businesses. There were very unequal impacts. The smaller businesses with less resources, financial resources, tended to be the most impacted compared to larger businesses. We found that there was actually a quite limited awareness of the problems in advance, even though there was a forecast of the El Nino event and an expectation that rainfall would be lower than average. But I think people were taken by surprise just by how extreme the event was that year. And what businesses were identifying as a primary issue was access to finance during the extreme event and the electricity load shedding. The figure shows the ranking given by businesses to different types of challenges that they face. And this is based on a standard questionnaire that the World Bank uses to understand challenges to businesses in different countries. And we followed the same questions as the World Bank survey. And what we found for Lusaka during 2015, 2016, or just after that, after the El Nino event, was the larger the circles here and the darker the color represents the higher priority or the highest significance or ranking of this particular challenge to business activity. And the two challenges there with the highest ranking you can see are electricity production or insecurity of electricity supply, and then access to finance were ranked highest by those businesses. So we get from that an indicator of the importance of this type of disruption associated with a very extreme drought event in the country. So just to finish up on this part of my presentation, then I wanted to highlight the fact that hydropower as a sector is, of course, very sensitive to climate and likely to be sensitive to climate change in the future. One of the implications of this for adaptation is that it's important for ministries of energy and ministries of water resources to coordinate and try to manage and anticipate dry events and a reduction in water availability and the effects of that on hydropower generation, and to implement contingency plans to try to reduce the impacts of those events as much as possible. And then in relation to more generally, in relation to water security and climate change, we are already facing high levels of variability, and this is across sub-Saharan Africa and North Africa, but also in other parts of the world now. That variability is increasing. For much of Africa, we're seeing emerging issues related to urbanization and the impacts of climate in urban contexts. We're also seeing, and I'll talk about this next as my final example, is this idea about interdependencies. So if we see impacts on water, there are consequences for energy production. There are also consequences for irrigated agriculture and food production and food security. So strong interdependencies across those sectors mean that we're dealing with quite complex and wide-ranging hazards that are occurring as a result of climate variability and climate change. And we need to be thinking very carefully about how we manage these extreme events, as I said just then, to think about the design and implementation of contingency plans. So my next example is, so far I've been talking about the past or the recent variability and climate extreme events and the significance and consequences of those for water security through my two examples. But my next example is one which is talking about the future. So what can we say about the availability of water in the future, and what are the challenges or the consequences of changes in water availability for managing a river basin? And I touched on this with my Nile example, but I have a much more detailed example now, taking some information from recent work that I was involved in Tanzania, in Tanzania's largest internal river basin, the Rufiji River Basin. It's an important basin that provides much of, again, the hydropower to the country, but it has also been earmarked for major development in terms of new infrastructure and in terms of, extending the area of irrigated agriculture. And the work that I'm going to present here, you can download. It's open access. So there is a chapter in this book called Climate Risk in Africa, which you can, if you Google this, you find the site for the book on the Palgrove publishers, and you can download the whole book, and it gives you some nice case study examples of climate change in different parts of Africa and approaches to adaptation, given the threats that climate change represents. So I'm going to talk in a bit more detail about the Rufiji River Basin example. Before I do that, I want to focus just broadly on the way in which we try as researchers to understand how climate change may affect society, economic activities as we move into the future. So the top part of this slide shows you the changes in climate that may occur into the future: sea level rise, temperature warming, and then precipitation changes in the timing and intensity of precipitation are all going to have impacts on different sectors, as we see here in the slide, across areas of health, agriculture, forestry, water resources, coastal areas, and species and biodiversity. To understand what those impacts might look like, we take information about the climate and we take information from climate models, which are complex computer simulations of the global climate system that we can run out into the future. And given the increasing concentrations of greenhouse gases, those climate models can give us an indication of the way the global temperature, but also the temperature distribution across countries, across oceans, the distribution and changes in precipitation that will occur with climate change, how that will evolve as we move out into the future. So we take results from global climate models, the changes in the climate, and we link those with models or understanding of systems like the health sector, like the agriculture sector, or in our case, the one that I'm going to show you now, the water resources sector. And we use that to understand if the world continues warming, if there is a change in precipitation, what are the impacts going to be on water resources in different parts of the world? And here I'm going to talk about the Rufiji Basin. Okay, so when we do this type of analysis, it's important for us to think about the kind of problem that we want to identify and understand. So we need to think about the problem that we're studying. So here, the rationale or the reason for the analysis that we're undertaking is that this is the map of the Rufiji Basin in Tanzania. It's the internal basin, the largest internal basin in Tanzania. And as I said before, the basin has been identified for irrigation expansion in these orange oval areas here. There are hydropower dams planned on the basin. In fact, there is what will become, when it's completed, it'll be Africa's second largest hydropower capacity dam in Africa, the Julius Nyerere hydropower project, which is being built downstream in the basin round about here and is currently under construction. Will generate a lot of electricity for the country. And in addition to the economic expansion plans for the basin, there is also high tourism value and high biodiversity value within the basin. So there are wetland systems and there are national parks where it's important to maintain the level of the water, the level of the river, to maintain habitats, to preserve the biodiversity and the wildlife in the national parks, and important economic income coming from tourism in the area. So the problem is, with these major plans for expanding and economic development within the basin, future climate risk, to what extent is future climate change going to compromise these development plans, the hydropower, the irrigation expansion, the environmental integrity within the basin? And that's what we're interested in. So to what extent will climate change compromise development objectives? That picture is one of the smaller hydropower dams within the basin. So to do this, we use a water resources simulation model. So this is a technical part where we use an understanding of the river flows, the different hydropower dams, the different irrigation schemes within the basin, and the physical effects of the wetland systems. And we divide it up into a computer simulation model of the dams, wetland systems, the rice irrigation abstractions. And we use this model to tell us what is the water availability at different points within the river basin, given the rainfall and the evaporation at different points within the basin. And with the model, we can add new dams to be able to predict what will be the implications of the dams for the river flows. Will there be enough water in the system for the dam to maintain the hydropower? Will there be enough water at different points within the river system to sustain the demand for water for irrigated agriculture within the system? And you can see from this that the river basin is already quite heavily utilized. There is, with the expansion plans, it will put increasing demands on water within the basin. And our analysis was to look at, given climate change in the future, will there be enough water in the system at different points within the tributaries of the Rufiji River to be able to sustain the hydropower production and the irrigated agriculture? So we can frame this in the sense of interdependencies across water, food, and energy and environment sectors, because as I was saying, the biodiversity is very important within the basin. And these are the development plans for the basin. So a plan to expand irrigation by up to 400,000 hectares, that will lead to increasing abstractions of around 6.2 billion cubic meters. And then, as I said, there is the Julius Nyerere hydropower project, which is under construction within the basin. Are we going to be able to maintain the reliable, sustainable production given climate change in the future? And to do this, it's important to identify what our stakeholders or the river basin managers, what are their priority concerns about water resources and their sustainability as we move into the future. So to do this, we spend quite a lot of time identifying what we call performance indicators. So what is it about the system behavior of the river basin that stakeholders are most concerned about going into the future? What do we need to ensure that we can sustainably produce in order to keep the priorities of the stakeholders met? So we identified, as part of this, we identified indicators around irrigation, and the prime one there, of course, and not surprisingly, is to maintain reliability of meeting irrigation water demand. For ecosystem services, the biodiversity within the basin, to ensure peak flow frequency downstream of the Julius Nyerere hydropower project. And then for hydropower production, of course, we want reliability in annual and monthly total annual production. So with our hydrological water resource system model, we looked at to what extent would we be able to meet these performance objectives in the future, given the changes that might occur in the climate. So we're trying to understand what is the climate risk to key performance indicators within the river basin. Just to demonstrate this slide shows the results. I mentioned the fact that we take results from global climate models. They give us information about changes in temperature and changes in rainfall moving out into the future. And the two panels here show, The top panel shows the percent change in future rainfall. And this is for the period of the 2050s as we go out into the future, about another 25 years from now. And each of these represents a different climate model from a different climate modeling group around the world. We can obtain their results through computer model data portals that are publicly available. And here, this shows the results for each of the climate models, and this is the percentage change in rainfall. So the red examples here are computer simulations which project a drying of rainfall in the future, and the blue models, the blue examples here show models which are suggesting it's going to get wetter in the future. And the lower panel here shows if we put these changes in rainfall into the hydrological model, it tells us what is the effects on the future. Oops. And you can see here that once we simulate the changes in rainfall in the hydrological model, we see that there is an increase in the number of or in the projections where it gets drier in the future. And that's because of higher temperatures and higher evaporation through the hydrological model. So we feed these results from climate models into the hydrological model, and that tells us about whether the impacts are going to be, or how significant the impacts are going to be. So I've dropped a slide from here. I don't know where that's gone from my presentation. So anyway, I'll talk through. I've got a missing slide. What we find when we do this for the Rufiji Basin is that there are quite complex impacts, and there are some positive impacts because we've got higher river flows in these examples. In these cases, we get some positive changes in the likelihood of being able to meet future demand for irrigation water and for hydropower. So we get some improvements, but with the models which are suggesting drier conditions in the future, then we get an increase in the likelihood of us being unable to meet the performance metrics for both the hydropower generation and the maintaining the biodiversity conditions for water within the basin. So there is a range of some positive effects and some negative effects, but the consequences of this and the implications that we've identified from doing this analysis is that there are, because of the strong interdependencies between food, water, and energy, we've identified the entry points to be able to make connections between the Ministry of Water Resources, the Ministry of Energy, Ministry of Agriculture, for them to co-design contingency plans to be able to deal with the consequences of these changes as they might occur in the future. So one of the key recommendations for adaptation is to improve the joint governance of water resources within the basin, and to design and develop and implement contingency plans for dealing with situations of low flows moving into the future. Okay, so sorry about that. I don't know where my final slide went, but I'm going to end now. I think you, how long have I had? Oh, my time is up. Okay. All right, yeah. So I'll wrap up.
Just on time, okay.
All right, a couple of key points. Okay. So adaptation is now unavoidable. We're locked in. The climate is changing, and that is going to bring heat waves, floods, droughts, and increasing variability. There are no blueprints for how we go about adapting in the future. We're all learning about how we can approach this, and sharing experiences across countries is a very helpful way of doing things. The local context, I think you will see that from my examples, is always very important when we talk about adaptation. And an important part of the process is that we need to have consultation with stakeholders in order to identify who or what is most vulnerable to what types of climate risks. Is it rainfall? Is it heat waves? And then what are the most realistic and effective responses, and who is best placed to take action and when? And then finally, just a couple of points to wrap up with, and that we need to be careful about too much technical complexity when we try to do these impacts assessments. They can be very technical and time consuming, so sometimes it's important to keep them simple. Climate change concerns are important to link with existing management systems and processes. So having an understanding of the way ministries and departments are currently working and how they might factor new risks into their operating processes is a good way forward. The recent extremes, such as the ones I've shown, those associated with El Nino, may highlight current sensitivity and vulnerability, and also effective responses, and that the many existing options are already present. Sometimes we call these low regrets. And then a key area for implementation is the design of contingency plans to help us with dealing with extreme events. Okay, good. Thank you. Thanks for staying with me. That was a long time of talking.
No,
I apologize.
Okay. Thanks a lot, Professor. It was like great presentation. I believe this would be like great reference for any like policymaker or like researcher who was like doing like some adaptation strategies. I believe we should go more for adaptation. This is like my own opinion, but like in the water sector, it's become very complicated, and even matching. You like mentioned about like matching people needs with the strategies is like extremely challenging. So thanks a lot for these guidelines, and I believe we are receiving some questions. So I'll ask on behalf of Mr. Muhammad. Mr. Muhammad Husni. So he's generally asking about like, oh yeah, you can ask directly if you
yes, yes, I can ask. I wanted to you said about the impact assessment and how the decision makers and the government take a contingency plan for the impact of the Nile rivers, but the results and the uncertainty for the many models. We have many scenarios and many models. What one we can depend on when we take a contingency, and this will cost us a huge amount of money to take this into considerations. When we take an impact assessment and take these actions in our considerations, which model we can depend on? There is a lot of scenarios. Can you understand my question?
Yes. One of my slides showed the different scenarios coming from climate models, and there are 20, 30. There are many, and those scenarios give different projections for the future. Some of them suggest dry and some of them suggest wet. So it is complicated. I think that's why I tend to suggest contingency plans, because there is uncertainty about the direction of change in the future. Then we don't know exactly what to plan for. And therefore, there are some principles that we want to try to keep our management flexible. We want to avoid what we sometimes call lock-in with expensive infrastructure that may not be effective in the future because of some of the changes that could occur. So we have to plan and include within our contingency planning a range of possibilities in the future, and to work through, if it becomes drier, what would be the consequences of the drying, and what would be the steps that we need to take during a drying period. How would we overcome that, and to identify those steps, and to work out, are there any of those that we can take now that are not too expensive? if some of the steps are very expensive, then we would need to try and work on improving our confidence before we make the investments. We would want to improve our confidence in those kinds of projections. So for contingency planning, the idea of it is that we work with different projections, both wetting and drying into the future. Does that answer?
Yes, thank you.
I mean, it's not a simple answer, and it's not a simple message to give to decision makers. It's a very tricky one. But that at the moment, in terms of the science and our ability to make projections of the future climate, we are limited in our ability to do that. There are some things that we're more confident in. We know that population is going to continue to grow, and we can look at the implications of that for water demand and so on. So there are some things that we can use to give us a good description of the future situation in terms of demand.
Okay, so thanks a lot. We have another question from Ms. Azza. So she's like leading editor in Egypt. So you can unmute yourself, Azza, and go ahead. We can't hear. Can you hear?
No, I can't hear anything. No. Perhaps you're on mute. I don't know. I can't see.
You may, Ahmed, ask directly because he already dropped his question on chat.
Okay. So I believe her question is also very connected to like the previous questions. So it's like she is asking about like maybe as you referred, society maybe is not so ready for like a very hard droughts. So, and she is moving to the Egyptian case. So she is presenting that in Egypt we have two paths of like how we address the situation to the public. So we have like some like we address the people inside Egypt for maybe our challenges in the Nile with like, okay, we are ready for the challenges. We have so much plans. We have a lot of investment and so. And for the others, we have the outside Egypt. She is saying that we are like promoting panic or so because like to like support our whatever position يعني. And then she is stating that she is saying that she as a journalist, she is when she is reading the outputs of researcher like you or like about the future of the Nile discharge. Some of the papers and models are like saying there will be, or even the IPC itself, it's saying like we have like some increase in the Nile River or so. But her direct question is, okay, so how ideologists behind this like how ideologists can like transform this information, and how like researchers and policymakers are like responsible for this. So this is like her basic question. Yeah. So how she as a journalist or like she's an editor, so how she as an editor can like figure out, okay, we have tons of studies, we have a lot of models, we have some people from here and some people from here. She can't figure out what's the truth. Yeah. Yes.
I think it is difficult to work out what simple messages might be, because it's a complex system, and also because there are different outcomes, and we're unclear about the outcomes. However, I always think it's very instructive to look at the past, because the past gives us examples of some of the variability that has already been experienced, and we can look at that, and we can look at what were the consequences of that variability. And a key example is the dry flow decade of the 1980s. If that was to reoccur, we can simulate what would happen given the current setup of the new reservoirs, the new dams within the basin. If the 1980s repeated, what would be the consequences of that? And in effect, there has been some work done to look at this, and to look at how would you need to manage the reservoirs in different parts of the basin, the Aswan Dam Reservoir, the Gerd Reservoir. How could you manage those together to reduce the consequences as much as possible of a dry flow event like that? And I think that there are combinations of options that can be implemented that mean the impacts are significantly reduced, but that involves some kind of agreement between upstream and downstream, some coordination between the upstream and the downstream, and it also would require that the authorities, both within countries and between countries, the authorities are clear about the contingency plan. What are the steps in the contingency plan that we need to take, and to make sure that we can take those? And that is that's a technical set of decisions, but it's also politically political, because the technical authorities need to have the capacity to be able to implement those, and communicating the importance of doing that to the public and the reasons for doing that is very important. And probably that is a role that the media can take, is to be clear about how it's necessary to make certain decisions in order to reduce the potential negative consequences if the system moves into a dry flow period. It might not happen, but it might happen. If it begins to happen, if there's 1 or 2 dry years, then you would really need to think carefully about implementing a contingency plan and getting the right communication to people about why that is being implemented.
Yes, I believe the last part also answer here second question. So for Muhammad Dabakir, so he is asking about, like, maybe even in his country Sudan, so he is saying, like, if a country like his country, maybe Egypt also, the agriculture is like in contribution, the GDP is going down, but still in Sudan extremely high. So he's asking from his country that in a country where agriculture economy is like a big in Sudan economy, I believe. So what's the best ways they can adopt to, like, if they have like less resources, and maybe I can add, if they have more floods, this is like a challenge also for Sudan. So what's the best practices they should follow?
It's difficult because I haven't worked on this recently, so I'm a bit out of date, and I'm not an economist or an agricultural economist to know what the best kinds of routes are in terms of the agriculture sector to deal with these types of threats. In relation to the floods, well, of course, early warning systems, better early warning systems, and advanced communication of floods when they're going to occur, and then ensuring that people have the ability to act on the early warning. So it's all very well giving an early warning of a flood event, but if people aren't able to relocate and move or do anything about it, then there's the value of the forecast is not great. So making sure you have early warning, making sure people are able to act effectively on the basis of that early warning is crucial in terms of floods, because it's quite likely that, well, we've talked a lot about water scarcity, but I've not said much about the changes in flood frequency. It's very likely that flooding will increase in frequency and intensity in the future. The other implications there would be for reservoir management. So whichever ministry is responsible for reservoir management, to be thinking about ensuring that you manage the level of the reservoir to allow some storage if there is a flood event, or that you have some alternative plans to be able to release excess water as floods occur. So to stay on top of your reservoir management.
Yes, again, Aza is asking, especially in extreme events, how much we should make the masses ready for this. Like, is the readiness of the masses of like a country of Egypt, like in a very extreme events, is doable? Yani, that's like.
Yeah, I don't know. You will know better than I do about the instances of urban floods and flash floods in Cairo, for example. I'm not sure. I should know, but I don't know about the incidence of that, whether that you were experiencing any increases. But yeah, that is becoming increasingly important, and their urban drainage is very, very important. Keeping the drains as clear as possible to allow water to run off as quickly as possible. Thinking about storage structures or might not be so relevant for Cairo, green infrastructure in parts of the city to make sure that you're thinking about that. But very much a question of urban planning, and for urban planners to be trying to ensure that they're taking into account a higher frequency intensity of flooding events in the future. And I mean, this is global. We all need to be doing this.
Yes. So I can't see any further questions. So maybe I have a final question for you.
Sure.
Yeah. Okay. So maybe I want like your just view on this issue. Like in a country in Egypt, or like in a country or Sudan, where we have like big reservoirs. So I know it's very challenging to like operate this reservoir, and maybe in the case of Egypt, for example, we have like two big reservoirs, which is Lake Nasser, and I believe it's hard for anyone, if you even get like the best professors all over the world to manage a reservoir which is like for like 110 million people, and then you have a history of droughts which could even drive the imagination of like the engineers who are working there. I myself like attend a lecture before, and like the professor was asking the one who is presenting about the Nile basin, and he's asking him, I feel you are overacting droughts in Egypt, and you are keeping most of the time the reservoir very high. We are like planning as if the drought is tomorrow, and I believe this could be missing some chances, and maybe putting a lot of continuous pressure on the people downstream, because like it's really, it will be like a catastrophe if we have like a drought, and then the one who is managing this big reservoir with the can commit a suicide. Yeah, that's it. Yeah. So it's extremely difficult. So how we can solve this one with the tools we have, that such a very big reservoir, and we have like 100 million people, and we still have what's the best management or strategies, or how we can build this?
I wish I knew to give you an answer to that. Gosh, that's a really difficult question. What's the best way of doing it? I think there are it's a complex system to know downstream whether you can optimize the water use downstream more effectively. If you can work a little bit on water use efficiency, there might be opportunities. If you do release more water, I think someone was telling me that you can have more navigation, more boats on the river, and that's good for tourism. If the river's deeper, you can have more tourist and leisure boats, and that's good for the economy. So there are interesting options that might be available for managing the releases from the dam more effectively for economic purposes, but for social purposes. And I suppose exploring those options and then trying to get the political will to support the technical managers in making those decisions, to help them and give them the legitimacy or give them the authority to make some of those decisions. But it's always going to be difficult. And whenever something goes wrong, of course, the people are very quick to blame the authorities and the technical decision makers. But that's I suppose the role, a role for the media is to try and show the nuances and show the complexities in the decision-making process, that it isn't easy to do this, and not necessarily mistakes, but challenges will arise because the climate's changing, we're experiencing more extremes and so on. So we will all feel this. Societies as a whole will feel the pinch as events occur, and maybe we need to be a bit more understanding of that, as long as we feel like the decisions are being made for the right reasons, and we hope that those are effective decisions and so on. Yeah, but if we don't develop contingency plans and we have to implement last minute problematic decisions, then of course people have a right to be upset about the outcome because it's inefficient.
Thanks a lot. Okay, so any final words or questions before we close this?
Yes, maybe ask
very quick, please.
Small questions, small technical questions.
Very quickly, please.
Yes, very quickly. Yes, Dr. Declan, I will return you by 30 years. Yes, Conway basin. Do you depend on the direct measurement for the flow, the river flow, or you have depend on the census and the statisticals to collect the measurements of the river Nile flow?
Yeah, so as I said, I'm a bit out of date. It's a long time since I used any observed data, but actually most of my work was using in situ observations. So the actual measurements are on the ground by the Department of Irrigation and by
in which part of the Nile rivers?
Well,
the point of measurement observations, the point of observation.
Right through from Egypt, Sudan, South Sudan into Uganda, but very limited observations in Ethiopia. There were very few observations of the river system of the Blue Nile until none before the 1960s really. And but you have observations for all the other parts of the basin, which go back to the 1900s, 1905, 1910. So you've got very rich historical data set. But now I know, there's a lot of papers coming out which are using remote sensing, and there's some really good technology that enables you to not know everything, but know a lot more than we used to be able to know just from observations. So probably a mix of both is the best combination.
Yes, thank you very much.
Okay, thanks a lot, Professor, for this great presentation. We have learned a lot today in many case studies in Africa, and I believe this could help all the participants to have solid ideas based on real cases. So thanks a lot for the lecture today.
Good, pleasure.
Have a nice day.
Thanks for the invitation, and lovely to meet you all. Thank you very much.
Excellent. Thanks.
Thank you.
Thank you, Prof.
Right.
Thank you very much.